Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management, right? And in this module we are trying to understand how does the operating system manage the CPU by providing this abstraction of a process, right? And in this second module, we are currently on the third topic, that is system calls, exceptions, and interrupts, right? So the idea behind this topic is to understand what are the different kind of events that happen during the life of a process and how these events help both the process and the operating system to communicate with each other, right? So we'll study about system calls, exceptions, and interrupts. All of these are in a way uh, all of these are communication methods. You can think of them as in such that they are communication methods that allow both the process and the operating system to communicate with each other, right? And in the previous video, I introduced the concept of system calls. We understood that system calls are like function calls, which the user process makes whenever it wants to request certain operations from the operating system, right? So, having talked about it at a very high level in the previous video, in this video, I want to we want to take a closer look at what exactly are system calls and what are the types of operations that these system calls offer, right? So let's look at the system calls in more detail and have a better understanding of them in this video. So without further ado, let's get started. So let us start the discussion with this basic understanding that we developed in the previous video. So here you can see there is the user application, and this is the main function, and this is the system call. So we talked about this in the previous video that the system call looks just like a function call. Here we have a dummy system call sys underscore call. And when this system call is invoked, you can see that the code for this routine, the syscall routine, is defined inside the operating system's code. Okay. So when the system call is invoked, the control is transferred to the system call routine, which is the sys underscore call, and the operation is performed. So now we'll study what are the different kind of operations that are part of the system calls, right? And as you can see in this diagram, after the operation is performed, the control is returned back with the results to the user process. So now let us understand what are the different type of services or operations that the operating system performs on behalf of the user process, right? So to start to understand this, let us recall the responsibilities of the operating system. So we have talked about this in the first module when we introduced the operating system itself. We said that the operating system has two major responsibilities. The first one is to make the computer hardware easy to use, and the second one is to ensure that the computer hardware is used in an efficient manner, right? And to make the computer hardware easy to use, the idea that the operating system follows is to come up with abstractions, right? And in order to ensure the efficiency, it does a careful resource management. So when we talk about system calls, we are more concerned about the first responsibility, that is making the system easy to use via the concept of abstractions. So let us see how. So this is the compute stack. Again, we have studied about the compute stack in the first module also, right? We said that the computer system can be visualized as a stack of multiple layers. So as you can see at the very bottom, there is the hardware, and you can see the different hardware components like the CPU, the memory, the IO devices, including the storage, and all of the physical components constitute the computer hardware. Then comes the operating system. This is the lowest level of software and the most fundamental piece of software that runs over the hardware. Then come the programming libraries, which make it easier to use the interface provided by the operating system. Then are the user applications, the applications that we run, and then the user interface with which the user interacts in order to use or launch these applications, right? So this was a brief review of the compute stack that we discussed in the first module, right? Now the thing here is that as you can see, the operating system builds a virtual machine over the physical computer hardware. So what do we mean when we say this? We basically mean that, so this is the real hardware, the physical hardware components. This is the real machine, okay? But the user applications kind of do not directly interact with the hardware. They interact with the interface that is exposed by the operating system. So what the operating system does is that for each computer hardware, in order to make it easy to use, it comes up with different abstractions. For example, We have talked about these abstractions in great detail in the first module also. For the CPU, the abstraction is that of a process. So a process is a running program, right? For the memory, the abstraction is that of an address space. An address space is a collection of addresses, right? And each process has its own address space, which helps it to view the memory, right? It provides the illusion of a private and large memory to each process. Every process has an address space. So this is the abstraction over the memory. And for the IO devices, we have files and directories. So you must have used files and directories, right? So these are you can think of them as a the most logical unit of persistent storage, right? So these contain information and they are used to both represent the storage and the IO devices. So we have talked about these abstractions in great detail. So the idea is that each abstraction, you can think of that as a virtual resource that has been built on top of the physical resource. So these are the physical actual resources, right? These are the hardware resources. On top of these physical resources, the operating system builds virtual resources. These resources are much more easier to use from the perspective of the user, and also they have many powerful capabilities as compared to the bare hardware resources. So the operating system, in a way, by providing these abstractions, it enhances the capabilities of the system and makes them very easy to use. So you can think of the operating system creating a virtual machine, which is a set of these abstractions over the real machine, and the user applications will not be interacting with the actual hardware directly. Instead, what they will do, they will interact with these abstractions, which are much more easier and powerful to use. So the point is that you can think of the operating system as the interface that the operating system exposes is like a virtual machine, which is much more easier to use. It is a collection of these abstractions. So this was about what the operating system does, right? We talked about the responsibilities. We are more concerned with the first responsibility, that is making the system easy to use by providing these abstractions. Now let's focus on these abstractions. So now the point is that, okay, the operating system has created these abstractions, but we need a way to use these abstractions. We need a way to perform operations on these abstractions, right? So let us talk about what are the different kinds of operations that we can expect or that we would require when we are using these abstractions. So for example, if you talk about the process, right? If you talk about the process, then we must have a way to create the process. We must have a way to terminate the process, pause it or resume it, right? So these are the different kinds of capabilities we need, that whenever we are using the process, these are the different capabilities that the operating system should provide us with, right? Another example is that of the address space. So we need a way, a mechanism in order to allocate more memory or deallocate memory in the address space that is provided by the operating system, right? So allocation and deallocation are important operations that should be supported by the operating system, right? Finally, if you talk about files and directories, then we should have simple operations like opening a file, closing it, reading data from the file, or writing to the file, right? Other operations could be like creating and deleting a file. And when I say file, I also mean the directory, right? So the thing is that, as you can see, these are the abstractions that the operating system created for us in order to make the computer hardware easy to use. Now, after creating these abstractions, it must also provide a way so that the user of the system, the user of this machine, the virtual machine, you can think, that the operating system has created, they should be able to use these abstractions. They should be able to perform operations on these abstractions, right? So now the answer to the question, that is how can we use these abstractions, is system calls. System calls are a mechanism via which the operating system allows us to perform operations on the abstractions that it provides, right? So for example, here are some examples of system calls. I have just shown them as function calls. I have not included the parameters, right? So these system calls are taken from the Unix based operating systems, okay? So here, let me just quickly go over the different system calls that I have listed. I will not go into detail, but just to give you a basic idea of how the system calls look like for the different operations, let me go over them. So fork and exec, these are system calls that are used during the creation of a process, right? Then wait system call, as the name suggests, it is used to wait upon a process to finish its execution. It is very useful when a parent process wants to wait on its child processes, right? Then there is this exit system call that is used to terminate a process. So you can see there are different operations that we can perform on the processes, and these system calls are some of the examples. Then mmap, these system calls are related to the address space. Mmap system call is used to allocate or used to map the addresses in the address space to the physical memory. Similarly, unmap is the opposite of mmap. It is used to unmap the mappings that we did from virtual memory to physical memory. Basically, these you can think of them as allocation and deallocation. BRK is a system call that is used to change the value of the heap section, the limit of the heap section. All of these system calls are related to the memory. Okay. Finally, let's talk about the files and directories. So as you can see, the names are kind of self-explanatory. Here, the open system call will be used to open a file. Close will be used to close a file. Similarly, the read and write will be used to perform the read and write operations on files. So these are the system calls, and via the system call, each system call is basically allowing us to perform some operation on the abstractions that the operating system provides. There could also be other system calls that are not directly involved with using the abstractions. They could be used to basically request some other kind of service from the operating system. It is not mandatory that it has to be related to some abstraction, but a majority of the system calls that the operating system provides, it provides them in order to, so that we can use these abstractions, we can perform some operations on these abstractions. So this is the basic idea behind what goes inside a system call, right? So the routines that are defined in the operating system, all of them, the system call routines are in a way for us to use the abstractions or do some other, request some other services from the operating system. So this is how the compute stack looks like. You can see this interface that the operating system provides. This is called the system call interface. And this system call interface is like a bunch of system calls, and each of these system calls is a way for the user applications to request some services from the operating system. It could be some operation on the abstractions. These are the abstractions that the operating system provides, or it could be some other service which might not be related to the abstractions, but the majority of the system calls are are there to perform some operations on the abstractions. Okay, then this is an example of how the system call, an example system call could look like. Okay, so here is the read system call. The read system call is used to read some data from the files, right? So you can see a system call looks just like a function call. You pass in certain arguments, and this system call, this function, this system call returns a return value. Okay, so let's go over this read system call. The first argument it takes is the file descriptor. It is like a file handle that is used to operate perform operations on the file. So the abstraction that we are concerned here is the files. Okay, then it is saying that read the data into this buffer, right? And how much data do you want to read? We want to read 10 bytes, and the return value is the number of bytes that was read. So basically, this read system call is saying that from the file whose file descriptor is fd, read 10 bytes and place them into the buffer buff, and the return value is how much bytes of data that were read. If the read system call is successful, then the return value would be 10, right? Otherwise it would be -1 or some other value. Okay, then this is the diagram that we've already seen, right? The system call is like a function call. It transfers control to the operating system. So extending this, right, here you can see there is one system call routine that is defined in the operating system. So the point here to understand is that all of the system calls are some kind of routine in the operating system. It is a function or a routine inside the operating system's code. So there will be several such system calls in the operating system's code base, right? You can see here, I have just, for the sake of illustration, I have shown n system calls, right? So the operating system provides a bunch of system calls for different purposes, right? And the user application can request the operating system the routine that it wants to be executed. It can request some operation, and whenever it has to request some operation from the operating system, the user application will make a system call. And when that happens, one of the appropriate routines will be invoked, and the operating system will perform that service or operation for the user application. So this is how the user application or the user process perceives the system call interface, or perceives the interface of the operating system. From the user application's perspective, the interface of the operating system is a bunch of system calls, right? And an operating system can hundreds of system calls. Modern day Unix based operating system have many system calls. The number is in few hundreds. Okay, and you can see the operating system appears as a library of system calls, right? A library is just a collection, right? This is a piece of these are different pieces of code that have already been implemented inside the operating system, and each routine in this library performs some kind of operation which the user process requires, right? So this is how the system calls operate. This is the basic idea of a system call. So basically, there are several resources, hardware resources in the system. The operating system, in order to simplify the usage of these resources, provides certain abstractions. We have talked about the abstractions, And then in order to use these abstractions, finally to use the hardware, the user processes request the operations via the mechanism of system calls. Each such system call looks like a function call, right? But the difference is that whenever you make such a function call, the control is transferred to some routine which is defined in the operating system's code base. Then the operating system fulfills or completes that operation and returns the results back to the user process. So this is how the system calls operate. What do they contain, right? So guys, this was it for this video. In this video, we looked at system calls in a more detailed way, right? So this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.